Professor McMahon touched on every major point because what he said was so important. If you'll forgive me, I would like to just revisit all of the major points. Just, these are important enough that I think some repetition might benefit. First off, our planet receives heat from the sun. In part, this is because of how far we are from the sun. But if that were the only variable, there would be no liquid ice on Earth. All right? So Venus and Earth would have very different temperatures if only their position from the sun mattered. It turns out that a lot of the sunlight that hits the Earth does not reflect back into space, but is caught by gases in the atmosphere. All right, so because, as Dr. McMahon pointed out, Mars without its atmosphere loses all this heat back up into space. We keep a significant portion of it. We have a greenhouse effect. We love the greenhouse effect. Our planet would be far colder if that wasn't the case. Professor McMahon pointed out, and forgive me while it just takes a second or two in between videos, that all sorts of radiation hits us. UV light, visible light, but once it hits Earth, it reflects back into space, mainly in the form of infrared or heat. All right. So the question is how warm our planet will get. This is not varying. The sun's input is the same. The question is how much of this do we keep? All right. If all of this went back into space, we would be freezing. There would be no liquid water on the planet. If we could block all of this, it would be 10 degrees centigrade warmer than it is now. So if it all goes up, it's really cold. If we block all of it, it's much warmer than it is now. And that's where these gases come in. They block some of it. How much of it will determine whether it is warmer than currently or not. Now, if we were to list our greenhouse gases, as Dr. McMahon pointed out, number one is water. Water is the major greenhouse gas. Why do we say that? Well, according to the American Chemical Society, the one thing you need to be a greenhouse gas, as you pointed out, was to have more than 2 atoms. All right, because it's the vibration which is going to absorb the infrared. And we don't measure that vibration if molecules that only have 2 atoms. So N2 does not absorb heat. O2 does not absorb heat. Water, H2O, 3 molecules, it absorbs heat. And a lot of this heat, or infrared, which is going up into space, therefore is absorbed by water. Where? Because, as Dr. McMahon pointed out, not every molecule can absorb every wavelength of infrared radiation. Well, water, as all molecules do, has its own specific IR spectrum. All right, so it will absorb these wavelengths. It will absorb these wavelengths. And I'd like to draw your attention to this. This is a window. Water does not absorb this. Water is more abundant than CO2 and the other things at the bottom of his chart. So if you were to release something into the air that absorbed this, who cares? It's not going to contribute to global warming because there's already water absorbing that heat. And by absorbing, what I mean is when these rays try to go back into space, they hit water, they vibrate, as Dr. McMahon pointed out, then they get lost back to the planet. The question is here in the window. This is going up into space. Anything that we produce that then absorbs UV light in that window will now warm the planet. Are there any such things? Well, we'll start with going down the list, CO2. CO2 absorbs IR in that window. Here's my water window, and then here is the spectrum of CO2. All right, so without CO2, all of this would go up into space. With CO2, any second now, all right, we get some of it. Now there's still a window. We're going to get back to that window. Notice there's more than 3 atoms, so the bonds can stretch, the bonds can bend. Bond stretching, bond bending is what allows it to absorb energy, and when it releases it again, this is what warms the planet. Okay? And so this is why we worry about the CO2 levels going from 317 in 1959 to in the 400s now, reaching, at least for a week, 410. All right. But there's more. There's methane, as Dr. McMahon pointed out. not a whole lot of methane. But we can introduce a term called global warming potential or global warming factor, all right? Because different molecules have different bonds, have different numbers of bonds, and therefore have different abilities to absorb heat. I'll get back to those spectra in just a second. So, this one methane, a kilogram of methane, has the same global warming potential as this much carbon dioxide, all right? So, obviously with our electricity and gas production, we're producing a lot of, carbon dioxide. But cows are producing a lot of that. The melting of the permafrost is producing a lot of that. The fracking industry is producing a lot of that. Now, nitrous oxide, which we release, as we fertilize our land, etc., has even a much higher one. 1 kilogram of nitrous oxide has a global warming potential around 300. So we don't produce as much of that, but nevertheless, we should measure that because it has a big effect. And then there's these other compounds where the global warming potential go into the thousands or tens of thousands. Now you might say that this is just a chemical we use on the insulation of wires, where there's just a little of this produced. Right, but it's tens of thousands of times more powerful as a greenhouse gas than carbon dioxide. You don't have to release that much of it to have an effect, especially if you're in one of those windows. Now, let's see. So what wavelengths does methane and nitrous oxide absorb? Well, as I'll just show you real quick, they're in the windows, all right? So notice that there is still light going back into space, all right, through those windows, all right? But methane, any second now, is there. It's in the windows. It gets light that otherwise goes up into space because it absorbs energy with bond stretching and bond bending. Nitrous oxide, the same. Ozone is also contributing with a little heat. So the big question today, all right, because we say, will these molecules absorb heat? And as Dr. McMahon pointed out, yes, there is zero doubt that these molecules absorb heat. Heat that would otherwise go into space, all right, is absorbed by these molecules in the atmosphere and reflected down. Now, some of this we need. There would be little life on Earth if there was no greenhouse effect. The gases which are here make our climate the way it is. Right? Now, as we'll see next week, as Professor O'Brien pointed out, this is cold. Our temperature now, this is not normal. This is colder than normal. In the Mesozoic era, so during those 200 plus million years, was there any case of ice at the poles, Professor O'Brien, in the Mesozoic?
The continents weren't at the same place. So if there's not a continent at the pole, you won't have any ice.
So we have a big chunk of ice at the South Pole, a big chunk of ice at the North Pole. No dinosaur ever existed at that time in our history. It used to be much warmer. This is colder than normal. If our planet were to get warmer, as Professor Bryan pointed out, would that end the planet? As you pointed out, would that be the end of the planet? No, this is cold, all right? It would not. Would it affect humanity? Yes, it would. So, once again, the health of humanity and the health of our planet, two different things. If it gets warmer, the planet will be here, all right? But us, and once again, we can get to this in future talks. How many people last year died prematurely with global warming as a contributing cause? Estimates are 350,000. And most of you would say, that's crazy. All right, well, how many people die each year of diarrhea? 2 million, mostly children.
It's worldwide?
Worldwide, all right. Now, bad water, malnutrition, forced migrations, these are all contributing factors. These may not be things that you think of. But when climate changes, this affects drought, it affects famine, it affects migrations. When we look at the aftermath of the hurricanes now, think of the standing water. Think of the mosquitoes, which can transmit disease. All right? I don't think this will directly affect you. You aren't concerned with the nematode worms, which are spread through dirty water. All right? But billions of people alive today have worm parasites. Billions. They will cause thousands and thousands of deaths this year. And if changing weather patterns affects nutrition, which affects health, if it affects where parasites can live throughout the world, if it affects heat waves, all right, which, as we have just tragically seen, when the temperatures go up, elderly individuals, as happened in that nursing home in Florida, are at a high risk. If there's a sudden heat wave, which is even just a few degrees hotter, if there's a hurricane which moves just a little bit differently or dumps just a little bit more water, some people die. All right. Now, areas of the world where the economic resources are less are more vulnerable. All right. When we look around the world, 1 in 7 people lives on less than $1 a day. 2 in 7 live on less than $2 a day. So changing the temperature a couple degrees or changing rainfall, it will probably not cost your life. But there are many people who died last year where that was not the case. And so we hope to look at this in multiple segments. But here the chemistry is undeniable. This absorbs heat. We put this up in the atmosphere and to measure how much we need tons. You are responsible for tons of heat-absorbing gases going into the atmosphere last year. What will this do? That's food for thought for future talks. We hope that you join us. I'd love anyone who has questions or comments, love to entertain those now. But once again, we hope to do this every week from this point through the end of the semester to treat the different aspects of this. Did anyone have any questions or comments?
I have a rebuttal.
Oh.
Actually, it's not a rebuttal. I just want to say that.
Never again.
When Dr. John asked me to do this presentation, I was happy to do it, still am, but we did not confer at all with each other. I had no idea what he was talking about, and he had no idea what I was going to talk about. So it was interesting to see how well the two things met, even though, like, he didn't tell me he was going to talk about what he talked about, I didn't tell him, but yet we really talked about the same things without knowing each other. So what does that mean? And if you look at the numbers we had, the numbers were actually all different, a little different from each other, but they were all the same, basically the same numbers. So we really agree together with what was said today. And I find that really amazing, just to point out, because that's really what science is. It's two people, or more obviously, coming together to discuss an issue from different points of view, different things, and guess what? We came to the same conclusion. Good job.
Any other questions or comments from anything else?
Question about how people are adjusting to this. In other words, have we been charting this? In other words, these effects, because you mentioned some case studies about with the nematodes and things like that. Because that's the interesting thing to have to say, are they adjusting to that, the changes in the temperature? How efficiently, how effectively?
Adjusting, obviously there's a biological aspect, there's evolution, and then there's the societal aspect. Evolution doesn't work fast, evolution works slow. So from a biological, there will be no change in human populations if 1,000 more people die of malaria this year as opposed to next year. Do societies change? I would like to think, and unfortunately there are so many variables. One of the slides, I might not be able to jump back into it, but where you can see how the amount of carbon produced in 1960 per person in the world, 3 tons, is different from now 5 tons. The rest of the world is looking at the developed nations and saying, we like that. We would love to live like you. We would love to have cars. We would love to have electricity. We would love to have air conditioning in the summer. We would love to have clean water systems instead of using latrines. And so I think that after, say, a flood, where there's standing water and more disease spreads, a country with resources would say, we're going to now put more in our public health to try to address that. A lot of countries don't have that. And if you're hit by a famine, and then there's severe weather, and you have now mass people on the move, a poor country, your resources are strapped. So what could you do? So I think it would vary. Like when we look at how our country will respond to the past hurricanes, I think we'll change how we drain water, etc. And so that might mitigate the effect of these in the past. What Bangladesh might do, or what I lived in Paraguay for 2 years, what Paraguay might do. I think they might like to do the same, but if your country is strapped after you just had a famine, there might be minimal response. So, Godfrey. Yeah, Mike.
Yeah, I just want to mention for anyone who is concerned that methane and fracking are dangerous for our environment, there is this power plant that's been under construction on Route 6 nearby us. And I want to tell you that if you believe this is something that is negative, that needs to be resisted, there are protests there every week at 11 o'clock on Saturday. And the more people come, the stronger the statement that is being made. So I hope in future we'll be talking about our local infrastructure too and how it contributes.
Thank you.
Didn't they actually shut down the pipeline, the government?
There's a decision has been made that prevents them from building the last bit of pipeline to reach the power plant. But that may not be the end of the story. That can be litigated, it can be redecided. And considering who's in Washington now, you can imagine if it goes all the way to Washington, it'll get approved. So it's not over, but currently there's kind of a block on it for the time being, but the issue is not done.
And just, we can get to this later. I care about this, but I'm old. The effects that this will have on me is minimal. The effects on you and your children, far greater. All right, and so we hope this interests you. We encourage you to get involved, as Mike just did, and we hope to see you in later seminars or by all means, best wishes with the remainder of your semester. Thank you for coming.